Final gathering is basically a technique to enhance global illumination and ray tracing. Global illumination on its own is very accurate and a very powerful way of modeling real-life lighting, and that's because it's a photon tracing technique. The problem is, in a complex scene, the number of photons needed to accurately model all the lighting in cracks and crevices through the scene is enormous, and you can hit some performance bottlenecks in that case. So what final gathering does is it basically completes the global illumination and ray tracing effect. So what happens is a final gathering map is created on disk, and basically it analyzes the scene for the visible surfaces only. So what's visible through the camera, a final gathering map is built for, and that file is written to disk. As the camera moves through the scene, more areas are exposed to the camera, and the final gathering information is calculated for those newly exposed areas, and it's added to the map file. So this map file grows and grows, and eventually contains all the final gathering information necessary for the entire scene. And basically, by adding more and more to the final gathering map, you're increasing the precision of that map, so that helps resolve any flickering or sampling problems. Next up, we'll look in more detail exactly how final gathering works. Final gathering is computed for visible surfaces only, and that information is cooked in the final gathering map. So it's basically a two-stage process where a final gathering map is computed, and then the ray tracer for any given intersection point will look up into the final gathering map file to get the indirect illumination. And it's this indirect illumination plus the direct illumination that come together to create the final pixel color for the intersection point. So looking at this in more detail, what we have is an eye ray shoots into the scene, and it will hit an object. That object's illumination shader or photon irradiance shader will then call a lookup into the final gathering map. So when computing the final gathering map, the first thing that's done is a hemisphere is created, and that hemisphere is aligned tangent to the surface normal. And it's basically composed of two components. There's an inner hemisphere, and that's represented by the minimum radius option. And there's an outer hemisphere, and that's represented by the maximum radius option. So once this hemisphere is built, final gathering rays can then be emitted from the hemisphere. So the accuracy option in the final gathering settings actually represents the number of final gathering rays that are emitted from each hemisphere. So for example, an accuracy of 200 will mean that 200 final gathering rays are shot out from each hemisphere. And it's these final gathering rays that actually evaluate the environment around that intersection point and return the indirect illumination value. So that indirect illumination value that's returned is then stored in the final gathering map to be used by the ray tracer later on. So now as the ray tracing process continues, you'll have other eye rays that shoot into the scene. If they fall within the min radius, it will actually just use the original eye ray final gathering sample. So no new final gathering samples need to be computed, and it's sort of a performance saver there. If you actually have eye rays that are shot and they fall outside the max radius of the original eye ray, a new hemisphere needs to be built, and new final gathering rays need to be emitted from that point to compute the indirect illumination for that point. So basically, final gathering is controlled by the accuracy setting and the min and max radius. And it's these three options that need to be balanced properly to create an accurate final gathering picture. And you always want to keep performance in mind. So next up, we're going to be looking at how accuracy in the min and max radius can be tuned properly to get a good final gathering effect but still have a performance scene.